So, hello, good afternoon. I hope your lunch was good. I hope your stomach is full, but your mind is still hungry for knowledge. My name is Christopher. I am an iOS developer at Polidea. We are a software house from Warsaw, Poland, specializing in apps communicating with hardware using Bluetooth or Wi-Fi. I also co-organize a meetup called Mobile Warsaw, but today I will be speaking about code readability. We are here at the Swift conference, so let's start by talking about Microsoft. In 2006, Microsoft, in collaboration with Carnegie Mellon University, published a paper called Maintaining Mental Models, a study of developer work habits. The authors conducted a survey among programmers working at Microsoft, and one of the questions they asked was whether a particular task was seen as a problem. The most often stated problem, reported by 2/3 of programmers, was understanding the rationale behind a piece of code. So how did those programmers try to overcome this? Mostly just by reading. Reading took over 40% of the time spent on solving this problem. When this was not enough, they tried running a debugger, adding print statements, and so on. If those also failed, they tried to get to the original author and ask them for an explanation. And if you're curious, what was the second most commonly stated problem? It was dealing with the requests from the teammates. Those teammates possibly came looking for help with understanding the code. When I read this article, even though I do not work at Microsoft, I found it very relatable. I've been both a person trying to understand the code and a person asked to explain what I wrote. And sometimes I couldn't really tell because the original author was me, but 6 months ago, and I wrote something I couldn't easily understand myself. So what insight can we gain from this research? That readability is the most contributing factor for understanding code. I think it's good to remind ourselves that because we tend to think about readability in terms of personal preferences and opinions. But it's much more than that. It makes a real impact on how we work. This is anything but a new idea. There is a lot of voices stating the importance of writing readable code. One example is this widely cited quote from Structure and Interpretation of Computer Programs book, which is, by the way, followed by a sentence I found fascinating, that we need to learn techniques to control the intellectual complexity embodied in the software. What a great way of thinking about what we do. Writing code means controlling the complexity. The more complex the system we write, the more difficult it becomes to understand. Some of the complexity is intrinsic, which means it comes from the logic that we are supposed to write. And we cannot do that much about this part. But there is also the incidental complexity, which is the part that we are introducing ourselves. This one is under our control, so to minimize it, we need to work extra hard on the readability of our code. But what does it mean exactly to write readable code? Let's play the readability game to find out. It's time for us to go for a quest. Our mission is to find a readability sweet spot. The first word we explore is the API design word. Imagine you've obtained the string representing an email, and you want to split it into an username and a domain. The basic approach we can take is something like this. So we split the string into parts separated by the @sign. Then we check that there are only 2 available parts. We bind them to the variables and ensure that they are not empty. And if anything fails, we return nil. If everything succeeds, we return a tuple containing the username as the first element and the domain as the second. So that's all. That's simple. Back to the readability. We are in the API design world, so let's concentrate on the method signature. Imagine seeing this signature for the first time. There are many questions that you may ask. How is the email split? What are the strings elements in a tuple? Why is the result an optional? Please enter the first level of readability game. Comments. So now we've added a detailed description of what's going on. So mission accomplished, right? Problem solved. Well, not really. Comments are a great tool for explaining the rationale behind the code, but they might also get quite confusing. Comments do not compile and do not execute in Swift. So it's only up to the developers to prevent them from falling out of sync with the code that they are describing. Comments are also a translation from the programming language to the natural language with the possibility of misunderstandings and omissions. Here we state that the argument cannot be split. It's not really true. I mean, we get nil also if the argument was split, but the username or domain were empty. Something was lost in translation. We could try to dodge those problems by using the Swift language itself. Please enter the second level of readability game, symbols. So we want to state that the email is split into the username and the domain. We can use a named tuple, probably behind the type alias, or a container struct. From the method signature point, there is no difference. Both those solutions share a common problem. They increase the number of symbols defined in a wrap. And each symbol carries two types of costs. Those costs will be paid by the reader. For the first time a fellow programmer sees split email, they need to check and understand what exactly this symbol means. So it's one more intermediary step. It's one more reference to keep in mind. This is the discoverability cost. For each another time, the cost of refreshing one's mind is going down because it's no longer an unfamiliar concept to learn. This is recognition cost. For this reason, there's no point in introducing a type that is used only once because the discoverability cost is fixed and the recognition cost is marginal. Also, note that standard library types are usually very cheap because the discoverability cost for them has been paid a long time ago and they are being refreshed constantly. So now our signature expresses the structure of split email. However, we haven't yet explained why the result type is an optional. Optionals are capturing the idea that the value might be missing. But they don't capture the reason why it's missing. Please enter the third level of readability game, a wrapper. So a wrapper is an extension of the container. It doesn't only store the values, but also provides some additional context. Here, we want to express that the passed string cannot be split into non-empty username and domain. Our wrapper enum does that by having two cases. One that keeps valid results as associated values, and the second one to indicate that the email was invalid. And if you would like to introduce more granular description, we could just another case. So this cleans our method signature of a question mark. But does it help or hurt the readability? Well, it depends. The way we model the idea of splitting an email becomes more complex. So the reader will now need to understand the rationale behind the enum with two cases and a lengthy initializer. The discoverability cost is growing higher. We can go even further in extracting the essence of splitting. Please enter the fourth level of readability game, concepts. So here we are using the Swift type system to grasp the very idea of splitting. Splitting is a process in which a single value is transformed into two values. We modeled the transform as a protocol with associated types, and then the email splitter becomes just one among many possible implementations of this splitter protocol. The operation can either succeed or fail, so the result is an enum with two cases. It's generic over the value type and the transform type, and it ensures that the transform can actually work. I have seen this pattern in Swift for the first time in a validated framework by Benjamin Entz, which I encourage you all to check. So now the result has its own type, the value has its own type, and the process of transforming the value into a result also has its own type. The signature contains all the same information that we have put into comments a few minutes ago, that we are splitting string-containing email using an email splitter into a possibly failing result of splitting. But does it make the code more or less readable? Well, it depends. If the idea of splitting is an important idea in our app, then we are going to have a lot of concrete types of splitters working on different values. By putting each one of them into the separate scope, we are going to deal with the intrinsic complexity. But if we have done all this work, if we have extracted all those types just to play with the method signature, we are only introducing the incidental complexity. We are obfuscating our code. We should have just written a comment and move on. So there went 4 levels, and it's the end of the first world. The princess is in another castle. We can already see there is no universal solution, only trade-offs. Maybe we'll have some more luck in the second word. So the second word is about delegation pattern. The delegate is defined with a protocol, and it's passed to the announcing object. When we express this concept in code, we're choosing among many possibilities. Should the delegate be assigned only once or multiple times? Is it optional or required? Should it be retained or not? Let's look how Apple answers these questions in their usual delegate implementation. So there is a public, mutable, weak delegate property. What information can we extract? At least 4 things. That the delegate is not retained because it's weak. That the delegate is not required because it can be never assigned. That the delegate can be changed during the lifetime of announcing object because it's a var. And that there is no harm in a free access to a delegate because the scope is open. And are those assumptions valid? Well, sometimes there is an explanation in the comments or in the docs, but often there is no answer there. Instead of docs, Apple is relying on the fact that it's a convention within their libraries that the delegates are not retained, they're optional, they can be changed, and that you should not really call their methods by yourselves. And the programming guides and the community, They share that knowledge among the new members so everyone is on the same page. But let's try to diverge from the choices Apple made. We want to have our delegate required and immutable. Please enter the first level of the second word, initializer injection. All we've done is we've changed the property visibility to private, and we've moved the assignment to initializer. Now it's impossible to create an announcing object without the delegate, and it's impossible to directly access a delegate from the outside. There is unfortunately some collateral damage. We have erased the information that the delegate is weak from the public API. Now, to make sure there will be no reference cycle, one has to read the implementation of announcing object. We can take a different route. Please enter the second level, a weak capture in a closure. Here, the responsibility to decide whether we want the announcing object to retain the delegate has been moved outside. The announcing object doesn't even know whether it stores the delegate strongly or weakly. However, would it be clear for a reader that the closure in the initializer is a way to avoid reference cycles? I don't think so. The closure is a language construct used in multiple ways, in multiple places, and there's nothing to specify its role here. Please enter the third level, the closure creation in a function. So the weak function is simply wrapping reference in a closure. Now it's explicit what we are passing to the announcing object. We are passing a wikified delegate. However, the rationale is still not clearly stated in the initializer's signature. It still takes a closure without specifying its role. We can try to improve that using the same technique that we have used in the first word of our readability game, the wrapper pattern. But wait, stop right there. Using a wrapper to improve the method signature? We have already been here before. We have already worked with type aliases and containers and concepts. We know there is no readability sweet spot waiting for us here. So this is the end of the second word. Also, is our improved delegation really that much more readable? We're not leveraging the convention that Apple provides, and there is a shared background for Cocoa developers. Driving away from them might only increase the understanding difficulties. So there is always a wider context in which our code exists. To write readable code, we need to look beyond what we control ourselves. So what shall we do? Should we move to another word? There are many words to choose from, but is there really any word that's going to bring us the ultimate solution? I don't think so. It looked like there is no castle with a princess inside. So how can we know how to write a readable code without a clear guidance? How to choose the right balance of the complexity, the symbols cost, leveraging conventions, explaining the role of language constructs, and many other factors. Fortunately, there is a God mode in the readability game, and it's called the empathy. To choose how to write readable code, we need to embrace the perspective of the reader. We need to imagine what they might be thinking, what questions they might ask. We need to put ourselves in the shoes of another person to identify whether we have chosen a reasonable set of trade-offs. So everyone is reading the code through the lens of their personal experience, their programming background, their fluency in Swift, their aesthetics, attention span. If we treat the code as a way to describe the system to another person, then just like with any other form of expression, we need to put the spotlight on the recipient. This is why I think there is no such thing as the readability. Because there is no readability without a reader. That's what makes the empathy so crucial. Readability is a function of a reader. It's a function that we need to choose where to land on. To win the readability game, we need to listen to the teammates and the community. And we need to remember that by thinking about others, we are also helping our future selves. There is no single right way to write code. What matters is being ready to learn and understand other people. If we stay open to feedback and we keep seeing value in the different perspectives, we can enjoy a top place at the readability game high score table. If you would like to discuss the ideas presented in this talk, or just chat about code readability and ways of improving communication within the team, I am here for you. Just grab me during the QA session or coffee break. Thank you.